You have this down? Yeah. All right. So again, what we're going over in the beginning is review. And again, not are you able to, but is it mathematically correct to add radicals? Is it mathematically correct to multiply radicals, not radicals? And is it mathematically correct to divide radicals? So something like this, root 2, is it safe to say that root 2 plus root 3 equals root 5?
Yeah.
Yes? No? Not sure? If you're not sure, use numbers that you know, like we know the square root of 4 and we know the square root of 9. What's the square root of 4? What's the square root of 9? What's 9 plus 4? What's 2 plus 3? Does that work? So is it mathematically correct or possible to add radicals? All right. So you can always do that on your own when you're not sure. Like, I'm not sure if I can do that. And I've shown you guys with this before, like knowing that this is not correct. You can do that with numbers as well. If you use the same numbers, 4 plus 9 quantity squared, is it safe to say that equals 4 squared plus 9 squared? No. What's 4 plus 9? 13. What's 13 squared? And is that the same as 16 plus 81? No. All right, so there's always things you can do. Is this rule okay? Is it mathematically correct? Try it with numbers that you know. All right. Next one. Root 5 times root 3. Is that say that equals root 15? No? Yes? Another one? Should we check it? Yes, let's try some we know. Root 4 and root, what was the other one I used? 9. What's 4 times 9? And what's the square root of 36? Would we get the same thing individually? What's the square root of 4? What's the square root of 9?
3.
Do we get the same answer?
Yes.
All right, so is that mathematically safe? Yes. All right, can we divide square root of 27 divided by square root of 3? Is that mathematically safe? I hear some maybes, yes. Division and multiplication work the same way, because do you agree you can write a division as a multiplication sign? Dividing by 2 is the same as multiplying by 1/2. So is it safe to do this one? Yes. You could write it like this, 27 over 3. All right, so yes. All right. We are going to move on to examples. Questions on what's mathematically allowed and what is not. Okay. Number 1. Square root of x plus 4 times another square root of x plus 11 equals 12. Okay. Are you ready? Multiplication and radicals. Are we okay to multiply them together and put them under one radical? Okay. Or another way to think of this, is this one term or two?
2 terms.
Why is it one term? Because it's a multiplication. It would be 2 terms if that multiplication was addition or subtraction. So don't write this down yet. Technically, could you go straight right now and square both sides? Yes. Why? Because this is one term. If you want to do it right away, that's fine, but I just want to show you the reason that does work is what we went through up here, right here. I can write it like this, one big square root and the product of x plus 4 and x plus 11. Are these two things the same? Yes? Because we just set up here, root 5 times root 3 is the same as root 15. You can write it under one radical. All right, so now what do we do to both sides? Square. So I just want to make sure you guys understand the difference on, I made a big deal with yesterday's notes with stuff like this, saying when you square both sides, you can't just square individual pieces. What's the difference? Why couldn't I square individual pieces here? Because there's a what sign? A subtraction. Addition or subtraction, you cannot distribute your exponent. There's two terms. Where here on the one that we're dealing with right now is one term. Do you see that? All right, so I am going to do two things at one time. The square and the radical undo each other, and I'm going to go ahead and FOIL this. And we know that 12 squared is 144. So go ahead and FOIL that. After you FOIL and combine your middle terms, what do you get? X squared plus 15x plus 44 equals 144, yes or no? Okay. What kind of problem is this? Is this where I'm going to get x squared by itself or get everything to one side? Everything to one side so that I can factor and solve. Again, we want to use, what is it called? The zero what? Zero product property. Thank you. Okay. And what does that come out to be? Negative 100. Double bubble. X and X. Is it minus minus, plus plus, or one of each? One of each. Think about it. What could it be? Anybody have it? 20 and 5 plus 20 minus 5. What does x equal? Negative 20, 5, and boom, I'm done. Why not? Good job. All right, did somebody check it already? Oh, even better. All right. Okay, so I was purposely waiting to see if anybody did stop me, and I'm very glad that you did. If I was taking the test and I did all this beautiful work, and on my answer line I wrote negative 20 and 5, is there a chance I might get it wrong?
Yes.
Yes. What are those solutions called? Extraneous. When you've done nothing wrong in your work, but the solutions just don't work. So let's try negative 20. What's negative 20 plus 4? And what's negative 20 plus 11? Negative 9. Now, I remember when I said yesterday or day before, and I said you have to plug it into the original, not after you've combined them, not after you squared them, because if you plugged them in right here, it just might work. But can I take the square root of a negative? No. Now you learned imaginaries last year. You worked with imaginary numbers last year, yes? And did your teacher, I know in Algebra 2 we used to make a big deal on when they're separated like this, you take out your i's first. So this would be 4i, and this would be 3i, right? And what happens when you multiply two i's together? You get I squared, which is, let me show you, 4i, 3i, 12i squared, which is negative 12. Does that come out to equal 12? No. Now I will have kids say, well, why don't you multiply them together first? Is negative 16 times negative 9 a positive number?
Yeah.
And then you could take the square root of a positive number. Do we all agree? Why am I not allowed to do that? Because I have to plug it into the original. And when you plug it into the original, they're two separate radicals, and you treat them separate. You cannot, when you're working this, you have to address the imaginary number first, square the imaginary, and get a negative. So, in the end, does negative 20 work? No. All right, did anybody try 5 already? What's 5 plus 4? Times what's 5 plus 11? And that one works. 3 times 4 is 12. All right, so our only answer is 5. Questions on that one? All right, number 2. square root of, I know, I didn't like the way that sounded either. X plus 3 equals the square root of x plus 1. Do you guys agree that that's a little funky there, the square root of, the square root of? Yeah, I agree with you, but guess what? It does come up on the test. Now, should I mark that? Like, if I were you, would you mark it and say, study this? Kids mess it up all the time. Now, what can we do? What can't we do? Do you guys agree there's 3 radicals here?
Yeah.
Now, ignoring the one on the inside, just ignore that guy for now. How many radicals do you have? 2. And we have to isolate. So it's kind of like what we did on block day. We talked about it then. When you have more than one, you pick the one you want to isolate. Is it safer, do you think, to isolate the one on the left that's already isolated, or isolate the smaller root x on the right-hand side? This one here. Do you agree it's bigger, it's already isolated, might as well isolate this guy. Now, is it safe to do this? And I need everybody listening. Square, square, square. And say root x plus 3 equals x plus 1. That is a big, huge, fat no. Do not make that mistake. I say it because kids make that mistake every year, and some of you will make that mistake, unfortunately, because you're not listening and then you forget. So study it, go over it, make sure you never, ever make that mistake. Yes, it's a lot easier to just go around squaring everything, but why can't I just do this on this particular side? Because I have 2 separate terms, and I can't just square individual terms. Okay, so I can square this side, and I can square this side like this, but this ends up being what? Double bubble, root x plus 1 times root x plus 1. Did we deal with these already? Have we seen these before?
Yeah.
Yep. This one, now does this square cancel out both the roots or just the outer one? Just the outer. So you have root x plus 3. Okay, I'm going to give you some time to FOIL. And remember, when there's double radicals, we always have to do step 1 again. So there will be a point where we come back to step 1. Bless you.
Thank you.
All right, guys, I hear way too much talking. Okay. Did any of you end up with this?
Yes.
Root x plus 3, that just kind of stayed the same. And here when I FOILed, root x times root x is just x. Root x times 1 is 1 root x. And then 1 times root x is another 1 root x. And 1 times 1 is 1. Yes? A mistake kids often make, and I see it on the test every year, is they do this. They write that one plus and that one minus. Is that correct? No. When this is squared and you write it twice, kids, I don't know why they want to put plus minus, but it's not. It's whatever this sign is twice. So if this was negative, I would have 2 negatives. All right. I've already combined like terms. Root x plus root x is 2 root x. I add the coefficients. That is safe to add coefficients as long as the root is the same. Okay. Like terms, move things around. Are we back to step 1?
Yes.
Now, how is this different from block days lesson? We're back to step 1, but we have a radical on both sides. Where on block days, once you got to this step, the radical was here and this side was clean, right? Okay. So do you want to subtract the root x to this side or subtract the 2 root x to that side? The root x to make it positive? Yes? Is there a question? Ask me, please. No? Okay. So I heard you guys say subtract root x. Gone. And that gives me 3 equals x, I'm going to put plus 1 in the beginning. And then what's 2 root x minus root x? Plus root x. Okay, so I just put x plus 1 all together. 2 root x minus 1 root x is 1 root x. And what am I going to do with this x and this 1? Minus it to the other side. And do you guys agree? I just finished step 1 in isolating the radical. Now, me personally, I can see I'm going to have to FOIL both sides, and I don't like foiling with a negative x in the front, so I'm going to write this as 2 minus x. Is that the same as negative x plus 2? And you can leave it as negative x plus 2. I just don't like to do that when I'm going to FOIL, but feel free if you'd like. All right, now we're on step 2 again, and step 2 is what? Yes, from block day, undo the radical, and how do I do that here? Okay, is this one where I can distribute? No, because there's 2 terms in here. What am I going to have to do? FOIL. And then root x squared is just x. All right, I'm going to let you guys FOIL that. And then what are you going to have to do after that? Get everything over to one side. Alright, I haven't factored yet, but this is where I'm at. Do you guys have that? X squared minus 5x plus 4 equals 0? If you do not, please go back and double check your work. This FOILed piece came out to 4 minus 4x plus x squared. 2 times 2 is 4. Negative 2x is negative 4x. Negative x times negative x is x squared. And then I just moved this guy over here and put it in the right order. X squared minus 5x plus 4. Questions on any one of those steps? All right, I'm going to move over here. I'm going to double bubble equal to 0. Has anybody done this step already? What did you factor to? Negative 4, negative 1, because negative 4 times negative 1 is positive 4. And then that gives me what? X equals 4 and 1. We're done? What do we have to do? Check. Which one do you want to check first? 1. All right. I'm just going to put some work here. We may need it. We may not. What's the square root of 1? And 1 plus 3? Okay, so root 4 equals, what's the square root of 1? 1 plus 1. Does that work? Square root of 4 is 2, and 1 plus 1 is 2. Did the 4 work? Yes or no? All right. 1. Wait, did I plug in the wrong one? Sorry. I just confused myself. I'm starting over. All right. And I'm going to write here this time what I'm checking. What are we checking first? And it doesn't matter. 4. All right. Square root of 4 plus 3 equals square root of 4 plus 1. All right. What's the square root of 4? 2. 2 plus 3, big square root. What's the square root of 4? 2 plus 1. 2 plus 3 is 5. Does it work? No. Does that mean you've done something wrong in your work? No, it's just an extraneous solution. And now I'm going to check x equals 1. So that gives me, in the very beginning, root of root 1 plus 3 equals root 1 plus 1. All right, what's the square root of 1? And 1 plus 3? And the square root of 4? What's the square root of 1? And 1 plus 1? Did that one work? Yes. All right, so we said 4 didn't work. X equals 1 is our only solution.
Is it possible for both of them to be extreme?
Yes. So just because you find one that doesn't work doesn't mean like, oh, the other one does. So yeah, you should check them both. All right. Definite need to know. So do you guys think if you got a little more practice with this, this is something you can handle on the test? No? With more practice. Guys, I always get kids, like, I don't know how to study for a math test. Going through your notebook, you have not only the problem, but all the work that backs it up. So take it home, cover this, and try to do it on your own again, or write in a separate piece of paper and try to do it on your own. And then compare it to the work you have there and see if it matches. And if it doesn't, check your steps. Got it? Okay. Number 3. Root x plus 2 times the 4th root of x equals 15. Root x plus 2 times the 4th root of x equals 15. Probably the most missed on the test. Yeah. Even though I tell kids, like, look out for this one, be careful with this one. So let's see if we can do anything like we did on the other tricky problems to figure out what we can recognize that this is one of the special problems. All right. Anybody tell me how this looks similar to problems we've done? There's radicals. And we have more than one radical, but that's okay. We've seen those before. Okay, so there's radicals just like there has been before. Anything different? Anything different? Okay, I see you've got it already. You're good. So some of you are not there yet. So anybody tell me what's different with this one from all the other radical problems? There is something different. What is that? Good. This one has a 4th root, and this one has a square root. Have we had any like that so far? Have we had any like this so far? No. So, on your homework, when we get our worksheet out, we'll look for these. Should you keep an eye out for these on the test as well? Make a mental note right now. When you see this on the test, and there's 2 different radicals, you are not going to do this at all like what we did on numbers 1 and 2. Or on block day, at all. Okay? I'm going to repeat that. When you have a problem that has 2 different radicals, a 4th root, a square root, a 6th root, a 3rd root, whatever it may be, you are not going to go through the isolate the radical, undo the radical, solve, and check. Completely different kind of problem. And that's the biggest mistake kids make. They get it by itself, and then they try to square both sides or 4th power both sides, and it ends up being a big mess. Are you guys ready on how to do it? Yes? All right. We change it. X to the 1/2 plus 2x to the 1/4. And I'm going to go to subtract that guy over. Minus 15 equals 0. Yeah, I just subtract him over so that I'm hoping you guys can recognize that as a particular problem. Now, have we seen this kind of problem before? Yes, not in this particular solving radicals piece. So I threw it in here because where do kids mess up? They see the radicals and they assume it's just like what we've been doing. Isolate, undo, and solve, and then check. And it's not. This is what we had a few lessons ago where it's a trinomial guess and check. Do you see that? Yeah. And how do we know? Because half of a half is 1/4. So we double bubble. And x, and what's the power? 1/4. And I keep asking this every time we do this. How do you guys know it's 1/4? It's the middle. Anyone else? How do you know that it's 1/4? Half of a half, half of your leading power.
So it's always going to be the middle one?
Yes, it's always the middle or always half of your first. And either way you think of it.
Just the smaller, like, fraction?
Yes. All right. I know there's going to be a plus and a minus because it's negative. Maggie, go ahead and give me the numbers, please.
-3 and +5.
Thank you. -3 and +5. Does everybody see that? Okay, so I have x to the 1/4 equals -5, and x to the 1/4 equals +3. Now, I didn't show each little step, but you guys see that I set equal to 0 and subtracted 5. Set equal to 0 and add 3. All right. Now we've been doing this a few times. Do I multiply by 4 or raise to the 4th power? Is there a difference? Yes. And now a lot of kids know what to do, but they just say it wrong. They say, oh yeah, multiply both sides by 4. No, raise both sides by 4. All right. So I'm going to do this one first because it's easier. 3 times 3 times 3 times 3 is 81. Negative 5 times negative 5 times negative 5 times negative 5 is 625. All right. Now, are we good? Is this the one I have to go back and check? Right here, this one I never really went back and checked. I did mess up somewhere, and I saw one person give me a little no nod when I wrote it down. Yes.
Isn't the negative factor negative 625?
Oh, is it negative 625? If I multiply negative 4 times, will they pair up to be a positive? Okay, so it is positive. That part is correct, but what were you going to say? To this piece here? Can you tell us why?
Because what you're raising it to is even and it's to negative.
Good job. That was the one another one I told you guys to look out for. That's an even power or an even radical, and that's an odd number. Is that mathematically possible? The 4th root of 625 is not negative 5, right? And there is no way to take the 4th root of even negative 625. Is the 4th root of negative 625 negative 5? No, there's imaginary numbers there. So this piece is mathematically impossible without using imaginary numbers. All right, so our only solution is what? And this is not one we have to plug back in because this was tricky. It wasn't really a radical problem. It was a trinomial guess and check problem. Do you see that? Yes? All right. Questions? Yes?
So you don't have to plug in for this one. It's only
The ones that you have to plug in, that you have to check, are when I put it in notes yesterday. It were these, where you're isolating the radical, undo the radical, solve, and then check. Those are the ones you have to check back to your original as is. The other ones you do not. Where you do check the other ones are to your restrictions. Those you should check at least to your restrictions when you have restrictions. Problems like this, you don't really have, well, not like that, like this right here. You don't really have to check until the end if you have time, because it's going to take a lot of time. All right? Okay, did everybody hear that? Okay, if you guys will please take your packets out so we can see what we're doing tonight. All right. Ladies, gentlemen. Okay, I want you guys quickly looking through worksheet 6, looking through worksheet 6 and trying to see if you can find those type of problems that we just did, the last one in notes, and circle them.
11.
Number 11, do you guys agree with him?
10.
Is there another one? 10? Okay, now that we've gone over them and now that we've talked about them, I'm hoping that these will not make you stumble in homework tonight. Got it? Okay, so what are we assigning? Odd, but I do want that extra trick. I don't mind assigning even, but I think you're giving odd answers, aren't you? I think he said all. All right. Odd adding number 10. Okay. Got it? Guys, and I do want to talk about actually number 9 really quick.
Can you walk through all of this with us?
All of them or number 9?
1, 3, 5, 7, and 9.
No. Okay. This would be 1/3 and this would be 1/6. And then half of 1/6. Sorry, half of 1/3 is 1/6. Said it backwards. All right. Shh. Guys, any suggestions? This is number 9, just at least how to start it. And there's more than one right answer. Again, this is one of your homework problems tonight. Any suggestions? And there's more than one right answer. Okay, I'm sorry, I didn't hear you. Common denominator. I would do that if I was adding. But since I'm not adding and I'm solving, do you mean, okay, let me take a step back. What did you mean by common denominator? Okay, because you could have used common denominator if you were clearing it. I just didn't know if you meant that or trying to add them together. But you're saying something different now. You're saying cross multiply? Yes. Are we allowed to cross multiply? Okay, root x times root x plus 7 equals 12. Is this one where I have to isolate? Can I isolate one of these radicals? They're multiplied, so I can't subtract them. I can divide them, but then I'm going right back to where I started. Right? So what do I do? Why? Now, your choice is you could square both sides here. Why are you allowed to when I keep saying you can't? You can't. Because it's one term. You are correct. If you don't like it that way, then write it this way. X times x plus 7, because it's a multiplication problem, equals 12, and then square both sides. And I'm stopping after this next step. X squared plus 7x equals 12. Because the square and the radical undo each other, I just distribute the x. I'm sorry. I meant to put 144. Thank you. All right. Are we good?